In this video, we're going to learn how to graph polar equations, specifically Limacons. Some polar graph can create some interesting shapes. And one of the most common examples of that is a Limacon. They come from equations like this. R, let me take a white here. R, it's equal to a number, a constant, added or subtracted to another constant that is going to be multiplied by sine of theta. Or R is going to be equal to the same, basically the same thing, a constant added or subtracted to another constant that is going to be multiplied by cosine of theta. Okay, these two forms will give us Limacons, and different kind of Limacons actually. A pretty common Limacon is a cardioid. A cardioid, it's a graph that is going to be something like this, right? It's called a cardioid because it looks like a heart. Okay, if we're adding sine, if we have an equation and we're adding by sine of theta, then our Limacon, it doesn't matter if it's going to be a cardioid or whatever other it could be, it's going to be stretched to the y, the positive y. Remember that this is not a rectangular coordinate, but we can use it as a guide, right? So we're going to go up. It's going to be stretched up. If it's negative, then it's going to be stretched down. It's going to be something like this. It's going to be like a heart, but like that. Okay. If it's cosine, we know that cosine is related to x. So if it's positive cosine, it's going to be to the right side. It's going to go like that. All right. And if it's negative cosine, then it's going to be towards the other way. Okay, so that's like our first characteristic that we can get out from the equations. Now, like I said at the beginning, we know that we have several types of Limacons, and we're going to identify which one is it doing a little test with these two constants. So if we test A divided by B and we get a number equal to 1, then we're going to get a cardioid. Okay, we're going to get a figure like this. Okay, we're going to get a figure like this, a cardioid. Okay, let me try to draw it a little bit more symmetric like that. Okay, so if we do a test and the test is dividing A by B and we get that is equal to 1, then our Limacon is going to be a cardioid. If it's positive sign, it's going to be like this. If it's negative, then it's going to be down. If it's cosine, positive cosine is going to be to the right. And if it's negative, cosine is going to stretch out to the left. Okay. If we do another test and we take A divided by B and we get a number less than 1, then our graph is going to look something like this. Okay. It's going to look like a one loop Limacon. So it's going to be something pretty similar to this. Okay. Pretty similar to that kind of heart. And again, if this will be positive sign, if it was negative, it's going to be towards the bottom, towards the y negative. If it is positive cosine, again to the right, and negative cosine to the left. Okay, if we do the same test and we get a number that is in between 1, a number in between 1 and 2, then our graph is going to look pretty much like this. It's going to be called a dimple Limacon. All right, and it's going to be dimple because it's never going to touch the pole in the polar coordinate grid. Okay, it's going to touch 1. So our Limacon is going to be pretty much like this. Okay, that one's a little bit funky. So like that. All right, that is our dimple Limacon. If in our test we get that A divided by B, it's in between 1 and 2. So if we do A divided by B and we get something greater than or equal than 2, then our Limacon is going to be called a convex Limacon, and it's going to look almost like a circle. All right, but with almost a flat side. So pretty much you can do it better if you have a polar grid probably, or if you're better than me at drawing. Let's try it again. So maybe it's going to be something like that. Okay, I cannot do it better. All right, so let's do a couple of examples of this to identify how to graph some Limacons. So let's suppose that we want to graph r, it's equal to 2 minus 5 sine of theta. Okay, so the first thing that we do is we do our test. So this is A and this is B, always positive. So 2 divided by B by 5 is going to be equal to 0.4. And this is a number less than 1. If we go back to our introduction, if it's less than 1, we know that we're getting a inner loop Limacon. Okay, this is the graph that we're going to get. All right, let's go back. How are we going to graph it in a way that it looks good and it almost represents the real thing? Okay, so we're going to get our axis, right? We're going to write our axis. Or 2x. Okay, so we know that we're going to graph sine, and sine is negative. So if we have this equation, we know that the graph is going to stretch towards the bottom. Okay, all right, so we know that. We know that our graph is going to stretch towards the bottom. So we know also, or we notice also, that we're going to get intersections for the horizontal axis, right? And that intersection is going to be represented by A. Okay, so if we had 2 as A, then our Limacon is going to intersect with the horizontal axis, 2 sides here, 2, 1, and 2. Remember that in the polar coordinate, we have basically circles. So we're going to be intersecting in these 2 circles. Well, in this circle and in both sides is what I mean. Okay, to know how much we're going to stretch out, we're going to take that 2 and we're going to add it to 5. So 2 plus 5 is going to be equal to 7. So now we know that the Limacon is going to stretch out towards, it is 7 because we know that it's going to be towards the bottom. So 1, 2, 3, 4, all right, 4, 5, 6, 7. So it's going to be around here, right? And all right, so if you notice from our introduction, we notice that there is a point in which the inner loop touches the axis. So we need to find that point. To find that point, we're going to get B subtracted with A. Minus 2 is equal to 3, right? Since we know that it's going to stretch out towards the bottom, and if you notice the inner loop stretch out in the same direction, then we know that this tree or the inner loop is going to be 1, 2, 3 right here, okay? Right there is going to be our inner loop. So if we try to graph this, we're going to get something pretty much like this. All right, this is going to be pretty much our Limacon, okay, for this graph. Remember, if you have a polar grid, it's going to be better to understand or to identify these intersections. Okay, let's try to do another example. Okay, let's try to graph r equal to 4 minus 2 cosine of theta. Again, we need to do the A divided by B test, and this is A, this is B, so 4 divided by 2 is equal to 2, right? And we know that if it's equal to 2, we go back, we're going to get a convex Limacon. It's going to be pretty much something like this, okay? These ones are a little bit easier. Let's identify some other characteristics from the equation. So we draw our vertical axis, a horizontal one. So if it's cosine, then it's going to open on the right or on the left side, this side or this side, all right? So, but since it's negative, it's going to be open towards this side, okay? Again, we know that if we add these 2 numbers, A plus B, so 4 plus 2 equals 6, we know how far it's going to stretch out. So we know that it's going to stretch out towards the left. So 1, 2, 3, 4, 5, 6. So right there. Okay. All right. Let's find our intersections. Our intersections are going to be defined again by A, and A is 4. So 1, 2, 3, 4. It's going to intersect this circle, and 1, 2, 3, 4 is going to intersect the same circle on this side. To find the point of intersection on the right side, okay, we're going to do the same method as in the one loop Limacon. So we're going to take 4 minus 2, that is equal to 2, and we're going to count 1 and 2. So it's going to intercept this circle. Okay, our Limacon is going to be something pretty similar to this. Okay, pretty similar to this, right? And it's going to be symmetrical. Right, this one can be drawn a little bit better. All right, something like that. Our limaçon is going to be a convex limaçon like that. Okay, let's do another example. In this case, let's graph 2 r, it's equal to 2 minus 2 cosine of theta. Okay, if we do the test, a divided by b will be 2 divided by 2. That is equal to 1. And we know that if it's equal to 1, then it's going to be this limaçon that is called a cardioid. Okay, to graph a cardioid, then we're going to do basically the same thing. We draw our horizontal or vertical axis on our horizontal one, okay? And we look at the equation and we know that it's cosine. Since it's negative, again, it's going to be stretched out towards the left side, okay? And we know that our graph is going to touch the pole because it's a cardioid, and cardioids touches the pole. Okay, so it's going to touch the pole. To find how much it's going to stretch is the same thing. We take 2 plus 2 is equal to 4. So 1, 2, 3, 4. It's going to stretch until this point. And the points of intersection are going to come from the same constant. So it's going to be A. Okay, so if A is 2, then we know that our points of intersection is going to be 1 and 2, the second circle here, and the same here, 1 and 2, the second circle here. Okay. After that, since we know that it touches the pole, then we just need to graph our limaçon. Okay, we can graph it like that. Well, on this side, it didn't touch the intersection point, but it's pretty much something like that. Okay, you don't have to do anything else since it touches the pole. Okay, let's do one more. All right, so let's graph r. It's equal to 5 plus 4 cosine of theta. Okay, let's do the A and B test. So A divided by B is equal to 5 over 4. Remember, this is A, this is B. A divided by 4, that is going to be 1.25. So this, it's in between 2 and 1, right? It's a number less than 2, but greater than 1. If we go back, then we know that it's going to be a dimple limaçon. See? So if our quotient is in between 1 and 2, then it's going to be a limaçon like this. Okay, so let's go back. And again, let's draw our two axes. Okay. In this case, we're going to graph cosine, and since it's positive, it's going to stretch out towards the right side. Okay. If it was sine, then it will be stretching out in this direction. Okay, so how are we going to identify? We know that it's going to be stretching out towards the right side. Since it's a dimple one, we know that it's going to touch 1. So right here. Okay, this first circle is going to touch that circle. Okay, let's find the intersection points. The circles that are going to be intersected is going to be 1, 2, 3, 4, 5 here, and 1, 2, 3, 4, 5 right here. Now, how are we going to know how far it's going to stretch out? The same thing. We take 5 plus 4. That's going to be equal to 9. And we just count the number of circles. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So here, and like this, we're going to have our limaçon. All right, something pretty much like that. Okay, so that's how you graph the 4 types of limaçons, given these two forms of equation. I hope that this video has been useful, and I left a free worksheet on pen as the first comment, so you can practice with this, and you should watch the next video about roses. Okay, so see you in the next one.